Hi guys, and welcome back to the ACE Academy. In this video, we will be speaking about the vertical shift in terms of the parabola. So what you guys can see on your screen right now is the natural parabola that we have plotted previously in the last two videos. And this is the exact same natural parabola. And this has the equation y is equal to x. So my question to you guys is, what would happen if I added some whole number to this function? How would that affect the change in shape of this function, or the way the function looks, rather? That's the question I have to you guys. Now, of course, if you already knew this, you wouldn't be watching this video in specific, but in order to understand this a bit better, I think that we need to do a little investigation together, right? So, in this situation, what I'm going to do is I'm going to write down the formula for the natural parabola, which is y is equal to x squared. Right. And now, just to make this a bit more interesting, I'm going to add the value of 1 to this equation. So the new equation will be y is equal to x squared plus 1. Right. So in order for us to understand the change that this addition of a single unit to the equation has on the shape of the function, on the way the function looks, we would have to plot it, right? This would just make it a bit easier for us to visualize it. So like any function, in order for us to plot, we're going to take the values from the x-axis, substitute it into our formula, obtain a corresponding y value, and we're going to plot that y value for the specific x value that we substituted. So starting off at 0, 0 squared is 0, plus 1 would be 1. 1 squared is 1, plus 1 would be 2. 2 squared is 4, plus 1 would be 5. 3 squared is 9, plus 1 would be 10. Negative 1 squared is 1, 1 plus 1 is 2. Negative 2 squared is 4, 4 plus 1 is 5. Negative 3 squared is 9, 9 plus 1 is 10. Now, if we had to join all of these points, we would of course get a new shape, a new parabola for us to work with. Okay, so I have joined these points together and I've obtained a new function. And that function is the yellow function on your screen right now. Now, if we observe this function carefully, we can see that the turning point has now shifted up by 1 unit. And in doing so, the entire function has been shifted up by a single unit. So when we add any whole number to the natural parabolic function, it will shift the function upwards by that many units. Understood? Now, what happens when I subtract something from my natural parabolic function? Now, in order to do this, I am going to manipulate my equation for a second time, and this would give me the equation y is equal to x squared minus 1. Now, if I plot this function, we should be able to obtain a new shape for this equation. So substituting it in, 0 squared is 0, minus 1 is negative 1. 1 squared is 1, minus 1 should be 0. 2 squared is 4, 4 minus 1 should be 3. 3 squared is 9, 9 minus 1 should be 8. Now, if I'm working towards the left-hand side of my y-axis, I'm looking at the negative x region. Negative 1 squared is positive 1. Positive 1 minus 1 should be 0. Negative 2 squared is 4. 4 minus 1 should be 3. Negative 3 squared is 9, and 9 minus 1 should be 8. And now we simply join the dots, connect the dots, and draw in our function. Okay, and now that the function has been plotted and sketched in, we can now observe the properties that this function has. The first thing that I want you guys to take note of is the fact that this function has a y-intercept at negative 1, which means the entire function has been shifted down by a single unit. Every single point that was previously used in the natural parabolic function has now shifted down by a single unit. The second thing I want you guys to take note of is the fact that this function has two new x-intercepts. Now, these two new x-intercepts are obtained because this function is symmetric, right? So if we shift the function downwards, any new x-intercept that has been created would be symmetrically created along the line of symmetry, which is our y-axis, right? And the reason for this is because this is a quadratic function. And now, what do we know about quadratic equations? When we look at the number 4 and we say square root of 4, we are able to obtain two answers for the square root of 4, because both 2 and negative 2 when squared can give us the answer of 4. Understood? So that is the theory behind why we obtain two different x-intercepts for the quadratic function. Okay, so for this vertical shift, this would of course have a standard equation, and this standard equation would be y is equal to x squared plus q, where our q value is our y-intercept, and it also tells us how far this function has been shifted. Okay, that's it from me for this video. All the best, guys, and I will see you in the next one.